Welcome to Applied Programming Lecture 8, Building Modern User Interfaces. We will start with an overview of what we have learned and what we are going to learn. And then we will continue with the main theory part, which is building modern user interfaces. We will learn about Angular material. And we will proceed with the hands-on section. Let us take a trip down the memory lane. We started this course with the first lecture where we had the introduction. In the second lecture, we talked about processes. In the third lecture, we learned about database or data layer. In the fourth lecture, we learned about the backend and we implemented a web API. And then came the brave new world, which is front-end and full stack and end-to-end application. So since lecture 5, we have been working on that. Previously on applied programming. Let's look into the theory part, what we have learned since lecture 5. We can group our learnings into 3 categories, the first one being the Angular fundamentals. There we learned a lot of things and we continue learning. The second part is data flow and the third part is product development. Let's look at what we have learned in which lecture. So in lecture 5, in terms of Angular fundamentals, we learned about Angular market context, Angular app structure, Angular components, and Angular templates. We also learned about front-end, back-end integration. Finally, we also looked into user experience. In lecture 6, regarding Angular fundamentals, we looked into JavaScript classes, we looked into TypeScript for C# programmers, and then we revisited components, but this time in depth. We did the same for templates, so we also studied them in depth. We learned about signals, and we learned about dependency injection. In lecture 7, we looked into data flow further, and we learned about validations. We also learned about product mindset. This week on Applied Programming, we are going to learn about modern user interface with Angular material. Let's do the same for the hands-on section. So previously on Applied Programming. And again, we are looking into the brave new world, which is the front-end part. So let's look into previously on Applied Programming since lecture 5. We started building components. So the first component we built is student card. And we had this analogy, and in this analogy, the components are like the dishes that are served in the restaurant. After student card, we also started creating models. The first model we created was the student model. We also had this continuing the same analogy. The models are actually similar to the menus in the restaurant. Then we made the student component use the student model. After that, we created our second component, which is called the student list component. We made sure that the student list component used both the student card component and the student model. Then in the exercises section of lecture 5, we did very similar things by creating a teacher card component, and then we created a teacher model, and we made the teacher component, teacher card component, use the teacher model. Then we created a teacher list component, and similar to the student list, we made sure that the teacher list component used both the teacher card component and the teacher model. Then in lecture 6, we added services. We first created a student service, and this was actually the thing that was making the API calls. We made student list and student card to use the student service, and we implemented delete functionality on student card. I forgot to mention, backend can be seen as the kitchen of the restaurant, and then as I said, services are making the API calls to the backend. And then in the exercises part of lecture 6, we extended the backend with the teacher entity. And the teacher entity is actually a data structure like in our model in the front end. We also extended the teacher controller, which is actually an API controller with the API methods, as well as we added a teacher repository. After working in the backend, we continued with the front end. We created a teacher service, and then we made teacher list and teacher card use the teacher service. Then in lecture 7, we created a new component. That is the edit student component. We connected the edit student to the student card. It actually also uses the student service and the student model. I didn't show it in the slide in order not to make it too crowded. We also added validation to edit student component. In the exercises part of the lecture 7, we also implemented delete functionality on teacher card component. We created an edit teacher component, which is similar to edit student. And then we connected edit teacher component to teacher card. Here it also uses the teacher service and teacher model. Just like with the edit student, I didn't show it in the slide, again not to make it too crowded, too busy. Last but not least, we also added validation to edit teacher. So this was, in a nutshell, previously on applied programming hands-on part. This week on applied programming hands-on part, we are going to add Angular material to our project. Angular material gives us continuing the analogy, it gives us the restaurant quality tools to make professional dishes. We will implement the toolbar, and then we will move the current links to the toolbar menu, and we will create an add student component, and we will connect it to the student service and add validation. Also in the exercises part, we will create an add teacher component, and then we will connect it to the teacher service and add validation here as well. Building modern web interfaces. Introduction to Angular Material. Angular Material is a user interface component library developed by the Angular team to implement Google's material design in Angular applications. It provides a set of reusable, well-tested, and accessible components that follow modern design principles. This library helps developers build consistent, responsive, and visually appealing interfaces quickly. Angular Material is developed and maintained by the Angular team in Google. It is tightly integrated with Angular and leverages Angular CDK component dev kit for low-level utilities like overlays and accessibility. Let me explain what I mean by overlay. Overlays are floating UI elements like dialogues, tooltips, or dropdowns that appear above the main content. Material design principles. Material design is a design language developed by Google. It was introduced at Google I/O 2014, which is an annual developer conference, as a unified design system for web and mobile apps. This launch marked a shift toward consistent cross-platform UI/UX standards, and it emphasizes clean, bold interfaces with intuitive motion and depth. Key principles include the use of surfaces and shadows to convey hierarchy, meaningful motion to guide user interaction, and responsive layouts that adapt to different screen sizes. Accessibility is also a core tenet, ensuring that interfaces are usable by everyone, including those with disabilities. This is a design language for consistency across platforms. Angular Material Architecture. This is a modular component library. Angular Material is built on top of Angular and TypeScript. It uses Angular CDK for foundational tools like accessibility, layout, and overlays. The architecture is modular, meaning you only import the components you need, which improves performance. It also supports theming through SCSS mixins, allowing for deep customizations. Let me explain first what a CSS is. It is a CSS preprocessor that adds features like variables, nesting, and functions. Let me also explain what mixin is. A mixin in SCSS is a reusable block of styles. Mixins help avoid repetition and enable dynamic styling. This library is tree shakeable. Tree shaking is a build optimization technique that removes unused code from the final bundle. Angular Material modules are tree shakeable, meaning only the components you import are included in your app, improving performance. Core Components Overview. Let's look at some of the most commonly used Angular Material components. Matte Button provides styled buttons with ripple effects. The ripple effect is a visual feedback animation that radiates outward from the point of interaction, for example, in a button click. It's part of Material Design's emphasis on motion and user feedback. Matte Toolbar is great for headers and navigation bars. Matte Card is used for displaying content in a structured format. A card is a container component used to display content like text, images, and actions in a structured format. It's ideal for dashboards, profile previews, and content blocks. Matte Dialog helps create modal dialogues. Matte Table is a powerful data table with sorting and filtering. Matte Form Field and Matte Input are essential for building forms. These components are designed to be accessible and responsive out of the box. What does responsive mean in this context? Responsive forms adapt to different screen sizes and orientations. Now I would like to show you some of the components that you can actually find in details in the link I provided in the slides. So let's start with the buttons. As you can see, Angular Material provides us with a variety of buttons, and you can see simple buttons, extended floating action buttons, and button groups, and icon buttons, segmented buttons, and split buttons. And then date and time pickers. Date pickers make it easy to input dates in the forms, for example. Similarly, time pickers also help us to select and set a specific time easily. Navigation components. We have navigation bar. It lets us switch between UI views on smaller devices. We have navigation drawer. It lets us to switch between UI views on larger devices. And then we have navigation rail, which lets us to switch between UI views on mid-sized devices. There are many more components in Angular material. I'll just talk about two more of them that we also use. First of all is the text fields. Text fields let users enter text into a user interface. And the second one is the menus, which display a list of choices on a temporary surface. Let us continue with theming and typography. Angular material supports both pre-built and custom themes. Pre-built themes include combinations like indigo pink and deep purple amber. For custom themes, you can use SCSS and define palettes for primary, accent, and worn colors. These primary, accent, and worn are three core color roles in Angular material themes. Primary means the main branding color, accent means the highlights or secondary actions, and worn means error or alert indicators. Typography can also be customized to match your brand. Dark mode is supported natively, which is increasingly important for user experience. Theming is powerful and allows for consistent styling across your application. Forms and reactive integration. Angular material integrates seamlessly with Angular forms. Mat form field wraps input controls and provides consistent styling and error handling. You can use reactive forms with form control and form group for dynamic form behavior. Let me explain. Form control is representing a single input field with its value and validation state. Form group, on the other hand, is a collection of form controls that can be validated together. It's used in reactive forms to manage form state programmatically. Validation is straightforward, and error messages can be displayed using mat error. This integration makes form development more structured and maintainable. Reactive forms are model-driven and use explicit form control objects. They offer fine-grained control over validation, dynamic form generation, and state tracking. Angular material integrates seamlessly with reactive forms for consistent UI and UX. Routing and navigation. Angular material provides components like mat site nav, mat toolbar, and mat list to build navigation layouts. Mat site nav is site navigation drawer. Mat toolbar is the top application bar. Mat list is the vertical list of items. These components work well with Angular Router to create dynamic, responsive navigation. You can use CSS Grid for layout management. CSS Grid is a layout system that allows two-dimensional placement of elements. It's ideal for complex layouts like dashboards. Angular material components can be styled using Grid for precise control. Angular animations can be added to enhance route transitions, improving the user experience. Angular animations animate transitions, states, and styles. Built on top of CSS, they enhance user experience by providing visual feedback and smooth transitions. Accessibility and internationalization. Accessibility is built into Angular material. Components support ARIA roles and keyboard navigations. ARIA stands for Accessible Rich Internet Applications. It, it defines semantic meaning for UI elements, improving accessibility for screen readers and assistive technologies. Angular material components include ARIA attributes by default. RTL, right-to-left support, is available for languages like Arabic and Hebrew. Angular material supports RTL languages by mirroring layouts and text direction. Screen reader compatibility ensures that visually impaired users can interact with our app. For internationalization, Angular I18 allows you to localize your app for different languages and regions. I18, it's actually read as internationalization, enables localization of apps for different languages and regions. It includes tools for extracting translatable text, formatting dates, numbers, and building locale-specific versions. We are continuing from the code after the exercises of the previous lecture, meaning lecture 7 or exercises 7. If you don't have the code, you can download it in Canvas under lecture 7, and the zip file is named as code after E07. Building and running instructions will not be repeated. It's the same as in the previous lectures. You just need to make sure that your database is running and your backend code is running and your front-end code is running. And after that, you need to test if your front-end can't fetch the data from the database. That is, if you can see the student and teacher records on the browser. Here I am actually running my backend code, and it's the API project that should start. And when it starts, I should see the Swagger with the endpoints that are available in our API. After that, I am creating a new instance of Visual Studio and running the front-end code. I need to install the npm packages, as it has a considerable size. I am not sharing all the packages, so every time you download the code you need to run npm install. And now I can see the two links, so let's see if it works by clicking on the links. Yes, I can fetch the student data and I can fetch the teacher data. Okay, today the first thing that we are going to do is to install the Angular material to our front end. We do that in the terminal, and then the command we use is ng add angular/material. This will install the latest version of Angular material. And we may be asked to choose a color palette during installation. It's not very important, but I chose the default one, which is Asia Blue. When it is successfully installed, the first thing we want to do in the hands-off session in terms of implementation is we would like to implement a toolbar. To be able to do that, we first need to go and work on the app.ts. Let me first remind you what we have in this TypeScript file. We first have the imports of student list, student card, teacher list, and teacher card. These are standalone components that we created. The components can be standalone since Angular 14 as an extra information. And then we import components, which is decorator to define metadata for the class, such as selector, template, etc. We also import signal, which is a reactivity system in Angular. We use it to create reactive value that automatically updates the template when it changes. We import the router outlet and router link. These are directives in Angular's built-in routing system. The first one marks, router outlet marks where Angular should render the component, and the second one, router link, lets us to navigate between routes. Then we are adding new imports. These are Angular material modules. Each of them provides a set of ready-to-use material design UI components. Mat icon module is for the mat icon element. Mat button module is for the mat button element, which is for buttons as we saw in the lecture. Mat toolbar module is for the top navigation bar or header. We import these modules so that we can use their components and directives in our template. Let's continue with the reminder on what we have in this code. Component decorator is where we define the root component of our Angular app. Here we have selectors, which in this case is app root. This means that our component will be used in HTML as inside angle brackets written app root, app-root. Imports is, since this is a standalone component, we must list all other components, directives, modules, it depends on here. We will add new imports very soon. Just to remind the rest, the template URL is the HTML file containing the layout, or which is app.html, and then the style URL is the CSS file for component specific styles, which in this case is app.css. And then comes the component class. This defines the class logic for the component. Protected read-only means that the title property is protected, meaning that it's accessible only inside this class and subclasses and cannot be reassigned. Signal, course admin system Angular. This creates a reactive signal holding the string course admin system Angular. We can bind this signal in our template using interpolation, namely inside double braces. Now we can continue with adding the imports inside the component decorator. We are adding these three modules that we imported above. Now we should also go make changes in the template app.html, and let me explain what we are doing here. We first add a new tag, mat-toolbar, that of course as we imported it comes from Angular material. What is it? It's a material design toolbar. It creates a horizontal bar, usually at the top of the page, for navigation, for titles, or for actions. It automatically applies material design styling, for example, the height, the color, the padding. We typically use it for headers or app bars, And the example, the result is, for example, a colored bar across the top with the app name and the menu. And then we have the menu button. Let's take it line by line. The button tag is regular HTML button tag. Mat icon button is a material directive that makes the button flat and designed for icons. Class example icon is an optional CSS class, and the ARIA label is for accessibility. For example, screen readers use it to announce what the button does. Inside the button we see mat icon brackets, which displays the material icon named menu. It renders a hamburger icon, the one that you will see soon, which has 3 horizontal bars on top of each other. Then we have the toolbar title, which is written inside the span tag, course admin system, that simply acts as the title inside our toolbar. We of course have the router outlet. Let me remind you what it is. It's a placeholder where Angular dynamically loads the component for the currently active route. So we can think of it as where should Angular display the page that corresponds to the URL. So when the user clicks the students, for example, Angular loads our student list. When the user clicks add student, Angular loads add student component. And when the user clicks teachers, Angular loads our teacher list component. This is basically how Angular single page app routing works. No full page reload, just swapping components inside the outlet. Then we also need to work on the styling app.css file. Even though it's very short, there's actually a lot happening conceptually here, especially since it's targeting an Angular material component. So let's look at it. The selector.mat-toolbar is a CSS class selector. It targets any HTML element that has the class name mat-toolbar. This line styles all material toolbars in our app. Then the property, that is the background-color. This CSS property sets the background color of the toolbar area, so when the browser renders the toolbar, the rectangular area behind the text and icons will be filled with solid red. How it interacts with Angular material. So Angular materials toolbar has a default background defined by its theme. Our CSS rule overrides that default theme color by explicitly setting the background to red. After saving our changes, we can immediately check the browser and we see that there is the toolbar, the color is red, and there is this hamburger icon. However, it doesn't work yet. Now the next thing we want to do is we want to move the items, the links inside the toolbar. So we again start working with the app.ts file. We need to make yet another import, and this time we are importing mat menu module. This is needed for the drop-down menus. We just save our file after adding to the imports, and then we again go to the template app.html. Now we are adding mat menu trigger 4. This is crucial. This is linking this button to a material menu, so that when clicked it opens the menu referenced by the menu name. The material menu is a drop-down menu component from Angular material. Mat-menu is a container that defines the menu structure. It's hidden by default and appears when triggered. And we create a template reference variable when we assign mat-menu to hash menu. so that we expose the Met menu instance. This is how it knows which menu to open. Inside the menu, each item is actually a button. Therefore, you see the HTML button tag. Met menu item styles the button as a material menu option. For example, it has this hovering effect and padding, etc. Then we have the router link to students. It tells Angular router to navigate to students when clicked. This is of course without reloading the whole page. So each menu item navigates to a different route. In our app, we have students to show the list of students, teachers to show the teachers list. All this works thanks to the router link and the router-outlet at the bottom. Now that we have moved the two items inside the toolbar, we don't need to keep the unordered HTML list, the two simple links, so we will now delete it until the router outlet. Next is the styling, but note that it's not app.css, it is styles.css this time. This is the global style sheet in our Angular project. So let's break it down line by line. We first make an import to Angular material pre-built themes indigo pink.css. This line imports this pre-built Angular material theme, the indigo pink theme, into our application. I mentioned in the lecture that Angular Material provides several pre-built themes we can use immediately that's located inside the package. And each of these themes have color palettes, typography, spacing, component shapes. So this single import line makes our entire app use the indigo primary and pink accent. Why it is important? Without importing a material theme, all the material components will appear unstyled, just plain HTML elements. So this import ensures that we use the proper material design visuals. And then I have reminders. So we have the HTML body. The HTML tag element is the root of our page, and the body tag contains all our visible content. By default, these elements only expand to fit their content. Here we are setting the height to 100%, so we ensure that the page always fills the full browser height. We also have body line. This block, the body block applies the base styles to our entire page body element. We can break down even further. Margin 0 means that we remove the browser's default page margin, because most browsers add roughly 8 pixels around the body by default. So when we do that, this actually ensures that our layout and material component will start at the very edge. So it's essential for consistent alignment. Then we see the font family, Roboto, Helvetica Neue, Sans Serif. So here we set the default font for our entire app. The Roboto is the official font for material design. It's used across Android and Google products. If Roboto isn't available, Helvetica is a good fallback. And then the sans serif ensures a clean, modern font if neither Roboto nor Helvetica is available. So this gives our whole app a professional typography that matches Angular Materials visual design. And let me remind again, this code is global, so these rules apply to our entire Angular app, not just one component. Previously we used app.css, now we use styles.css. Why is that? So app.css has local component level scope, whereas styles.css has global application-wide scope. App.css only affects the app component and template. Styles.css affects every component in our entire app. So as a best practice recommendation, if we want to change the material theme colors or reset margins or global typography or create reusable utility classes, then we need to put the styles in styles.css. If we want to add styling for a specific page component, then we need to use the component CSS file, for example app.css. If we want to override Angular material for one specific toolbar, then we can again use app.css. If we save our changes, then we should be able to see the effect immediately. See, when I click the menu now, I can see both items, student and teachers. So the hamburger icon and the menu actually works. At this point, we can view the students, we can delete students. Now we would like to add students. And in order to do that, you remember the command in the terminal ng generate component add student or ng gc add component. Next is we start working with the TypeScript file of add student. And let me again try to walk you through what we have here. First we have the imports. Of course we are bringing in dependencies. So we start with the Angular, we add the Angular material modules that are used to style and structure our form inputs. Met form field module provides container for inputs, for example floating labels, error messages. Met input module is the input directive, it's material styled inputs. The next one we already seen in the previous step, but let me repeat, Met button module is the directive for material styled buttons. Altogether they make our form look like a modern material design form. After the imports we have the component decorator. This tells Angular how to use this class, similar to how I explained before, so I will not repeat what it does. And then comes the add student class. We will look at it and implement it in the next steps. Now we go to the template add student.html. So this HTML template will be a good example of a reactive form in Angular combined with Angular Material UI. The form allows us, the user actually, to input a student's information and shows real-time validation messages using Angular's if control flow syntax. While adding the code, let's also walk through in detail, line by line and concept by concept. So we start with mat form field, that is the material input container. So each input is wrapped in a material design form field. What's happening here? Mat form field provides a style container with floating label and error handling. Mat label is the label text shown above or inside the input. Mat input is the material style input field. The mat input directive tells Angular Material to apply its design system. We repeat the pattern for each field, and each subsequent form field follows the same structure. And then we add a button. So let me explain what we have inside the button tag. So we first have mat-raised-button, which means Angular material raised style button. So it adds elevation and color. We have inside parentheses click add student method, so it calls the component method add student when clicked. So what happens here? When the button is clicked, it executes the function from our TypeScript file, which calls addStudent method. Now we need to go to app.routes.ts. This is our Angular routing configuration, which defines how users move between pages or between components in our Angular application. This file tells Angular's router which component to load when a specific URL path is visited. Let's break it down in a simple structured detail so that we understand exactly what every part does. We first import the dependencies, we import the routes from Angular router module. Reminder, a route is simply an object that maps a URL path to a component. So routes is an array of those objects. We can think of it like a map. When the user goes to /students, show the student list component. Then we import student list, teacher list, edit student, edit teacher, and add student. These are all standalone components that we created in our app, and each one is actually a separate screen or separate page. Then we declare the routes. First of all, routes is an array of route definitions, and each route defines what happens when the app's URL matches a certain path. Routes array is exported so that it can be used by router module in our app setup. We use this in app.config.ts, which tells Angular to use this routing configuration for navigation. So when we look at each object has a path and a component. Now we are adding a new route for add student. We are saying that it will open a form for adding a new student, the form that we wrote earlier. How it works in the app is we configured these routes, we tell Angular to use them in this app.config.ts. In our main app template, which is app.html, we include tags router-outlet, which is a placeholder where Angular dynamically loads the right component here. When a user clicks a link, for example the students button, students link, Angular doesn't reload the page, it just changes the URL and loads the student list component into the router outlet. The app feels like a single page app, instant navigation, and no page reloads. Now we go back to the template app.html, and as you remember, we have two menu items. These are actually buttons, and now we also add the third one, which is add students. We just need to change or write the correct path, as well as write the correct name or title for it. After that, we can just save all the files that we edited and then check the browser. So when we click the hamburger icon, we should be able to see add student. There we go, we see that. And then we see that there's a problem. So all the fields are in the same row. That wasn't what we intended. So it shows that we forgot one thing in the HTML template, and that one thing is this BR tag, which actually in HTML takes us to the next line. So after each met form field block, we have to add a BR tag, and that's what we are going to do now. And we can save the file and quickly check, and the problem is solved. Now we can see the input files are actually on top of each other in a vertical layout. At the bottom there's the add button. Okay, so now let's add some basic validation. We learned about validation theory and practice in the previous lecture. So here we start with the add student .ts, and we start with importing new things, which are form control, form group, forms module, reactive forms module, and validators that we are importing from Angular Forms. These are Angular Form API classes that are used for handling user input and validation. I can quickly explain one by one. Form control represents a single form input, for example, first name, for example, email. So form control tracks its value and validation state. Form group, however, it groups multiple form controls into a logical form. And then we have the forms module that we use it for the template driven approach, and we have the reactive forms module that's required for Angular enabling the reactive forms. Here we will be using the validation using reactive forms. Then we have the validators, that's the built-in validation function. For example, required, we will see soon, email or pattern. We import the student service, that's our customer Angular service that you know, which handles the communication with our backend API. So we send a new student to our ASP.NET Core Web API, for example, via HTTP post using our student service. We also import the common module, which provides common Angular directives, and we import the router, that's the service allowing programmatic navigation between pages. So for example, redirecting the students after adding a student. In the component class, we have the constructor, and as usual we have the dependency injection, which gives the component access to services. We have the student service that's used to call the backend API. We have the router that's used to navigate after successfully adding a student. Then we have the form controls. So for each of the items like first name, last name, study program, date of birth, email, phone, each of them represents an input field in our form. They hold, for example, an initial value that's inside the quotation marks. Often it's empty. For example, in study program ID, the default initial value is 1. Then we have a list of validators. So, for example, if you look at the email, the validator's email, the email field starts empty, but it's required and must match an email pattern. So, the validators that I used here, we have the required validator, which means field cannot be empty. We have the email validator, which means the input has to be a valid email format. Then we have the validators pattern. We have two examples. We have this double backslash d plus. It means that the input must contain only digits. And then we also have this d inside the braces 8, which means that it must be exactly 8 digits. Then we group the controls together inside student form group. This combines all individual form controls into a single form group object that's named student form group. When we bind this form group to our form in the HTML template, Angular will then automatically track validation for the whole form and disable the submit button if the input is invalid. It will also provide access to all control values through student form group.value. And now it's the time to implement the addStudent method. So we will use it for handling form submissions. Before doing anything, our code checks if the form is valid, or in other words, all required fields and patterns are satisfied. If it is invalid, it logs an error and exits. Then we call the service. We send an object to the student service.addStudent method. This will make an HTTP post request to our backend API. We will implement that in the next steps. Note that ID equals to 0 will be ignored by the backend since it will assign a new ID. We use subscribe method because addStudent method returns an observable, which is actually a HTTP call in this case. And then the next runs when the request succeeds. It logs success and redirects to /students. The error runs when something fails, for example, a network error. So the user gets redirected back to the student list once the new student is successfully added. So we have errors on add student and err, but these are expected. This will be fixed in the next steps. However, I am deleting some unnecessary braces and also fixing some errors in the code. Little bit of using too much autocomplete. There is also one error with the date of birth. It has to be a date type. After I also fix that, we are ready to go. As I said, there's an error add student, but it will be fixed in the next steps, and we continue with the add student HTML. Let me explain you what happens here. We first have the outer tag, the form tag. It has a form group directive which binds this form to a form group object defined in the TypeScript file. This allows Angular to track the validation state, so valid or invalid, reactively update the model when the user types, and control submit behavior. We can think of it as connecting our HTML form to the logic in our TypeScript. So the element form control name binds the input to the form control. For example, if form control name is first name, then it binds first name in our form group. Then we have the validation displays. We use the if at if syntax, which is relatively new syntax. It checks whether this form control, for example, first name, has a specific validation error, in this case required. If the user leaves the field empty, Angular's validation system adds a required error. So this block displays first name is required. And automatically it's styled by Angular material. So for example, it's red text below the input. Talking about the study program field, we use two validation checks there. We have required, we just explained what it does. Now we also have pattern. Pattern must match a numeric regular expression, in this case d plus from the component. So if the user types alphabetic characters like ABC, the pattern validator will fail and show the warning that we write here. Let's move on to the field date of birth. So input type date uses the browser's date picker. We only have required validation type here. But in email, we use validators.required as well as validators.email from the TypeScript file. And we display different error messages depending on which validation fails. So if it is empty, we show one thing, and then if it's not a valid email format, we show another thing. For the phone, we use the validators required as well as validators pattern. In this case, it has to be exactly 8 digits. If the user types letters, or if the user types fewer or more than 8 digits, it triggers the pattern error message. Then we have the submit message. We explained part of it, but I can repeat. Mat raised button is Angular material raise style button. It adds elevation and color. And then when we say color is primary, it uses the theme's primary color. And the disabled part says that if the form is invalid, then disables the button. And the click event, we already heard it a couple of times, calls the component method addStudent when clicked. So the user cannot submit until all validations pass. And when the submit button is clicked, it executes the function from our TypeScript file, which calls student service that addStudent method, and then it sends the data to the API and redirects to the student list page. We have the if control flow syntax, and it's as I said, relatively new, more powerful, easy to read. And when we use it here, we can also use else blocks or nested conditions in a cleaner way. The flow of the form is when the user types, the Angular tracks each input field. Each keystroke updates the validation status. If a field becomes invalid, Angular sets an error, which can be the required or pattern validation, and then the if blocks detect those errors and show error messages. The submit button is disabled until the entire form group is valid. Once it is valid, clicking add triggers addStudent method in our component, which sends the data to the backend. So here in this code we actually see several concepts. We have the reactive form binding, that's form group connecting form to the TypeScript logic. We have form control binding, that is form control name linking each input to a control in the form group. We use material design, as you saw, mat form field and mat input creates styled accessible UI. We use validation, as you see, the if blocks dynamically shows the messages, and we use the submit button control, which is disabled until the form is valid. And the last thing we need to do is actually working on the student service. Remember that the addStudent TS still has this error, and this is how we will fix that. So student service code handles all communication between our front end, the Angular app, and our backend, the ASP.NET Core Web API. It uses Angular's built-in HTTP client to send HTTP requests such as get, post, put, delete to our API endpoints related to students. Let's go through it line by line and explain what happens. We again have import statements. We import Angular's HTTP client service. That's the core API for making HTTP requests from our front end. We can think of it as Angular's browser communication tool. We also import injectable decorators, which marks this class as a service that can be injected into the other components or services using Angular's dependency injection system. You will remember from the constructors. We import Angular's HTTP methods, observable, because Angular's HTTP methods return observables. An observable is a data stream that you can subscribe to. It's perfect for handling asynchronous data like API calls. Then we import our TypeScript model or interface, the student model, which defines the structure of a student object. When we implement as is and we use the models, it gives us type safety as well as auto completion with IntelliSense in Visual Studio Code. We have the injectable decorator. It means that it tells Angular that the student service should be provided at the root level. It is a singleton service that can be used anywhere in the app without needing to register it manually in a module. So we can inject it into any component in the constructor, and Angular automatically provides the same instance everywhere. We define the class, the student service class. It's where our API related logic lives, instead of spreading HTTP code throughout multiple components. We have the base URL line, which is the base address of our backend API. So, for example, if it is localhost port 5050/API/student, it's the endpoint for getting all the students. Or if it is localhost with the correct port /API/student/ a number, for example 1, it's the endpoint for getting the one student with the ID equals to 1. And then if we keep the base URL here, it also makes it easier to change later. So for example, if we want to move to a production, then we might have a real URL or a commercial URL instead of localhost, and then we can change it here. We have the constructor I already mentioned. We have the dependency injection so that we can give the service access to Angular's HTTP client. Then we have the API calls or the service methods. Each method corresponds to an HTTP operation on our backend's controller. If we look at it one by one, we have get students, which fetches all the students. The backend returns a list of students or array of student objects. We have get student with parameter ID. It fetches one student by ID. It sends a get request to the API, and the backend returns one student record. We have create student. It creates a new student by sending a post request to the API, and the argument the student is the request body, the student data to send to the server. Backend creates a new record and returns a response. We have update student. It sends a put request, and put means update existing records. So the backend uses the ID inside the student object to find and update the correct record. We have delete student. It sends a delete request to the API, and the backend deletes that student record. Now we added add student, which actually is a duplicate of create student. It does the same thing as create student, but here for semantic clarity, so that the components can call add student, we just had it for learning purposes. We could in fact safely remove one of them and then just use the other. So summary, our student service is a bridge between Angular and Web API. It provides a clean, reusable, centralized way to handle all student-related HTTP requests. As you can see, when we save this, the error in add student also disappeared, because now we have it in the service, and now it's time to test if it really works. We have the add student form, and let's fill in the form. We cannot leave the first name, we get the error message, so we enter it. We cannot leave the last name, we also see the error message. We have a default value in study program. If we replace it with a character, non-numeric character, then we will also get the error message. See, study program must be a number, and then we have the date of birth. We cannot leave it empty. Email also cannot be left empty. In addition, email has to have a specific format, so we cannot just write anything there. Finally, phone has to be exactly 8 digits. Now that we entered exactly 8 digits and then we filled all the fields correctly, let's check if it works. And we see that it didn't work. Actually, it didn't add a record. So now let's try to debug it. We first need to make sure that if we entered everything correctly, so let's go back at student and then quickly enter in a different set of values that pass the validation checks. The add button and then check the students list and scroll down, and unfortunately it didn't work again, so we definitely have a mistake. So let's try to debug it together. So one way to debug it is to use the browser's developer tools, and let's go to JavaScript console. There we see some errors. Now, when we look at the error, we see that JSON value could not be converted to system.datetime. It is a clear indicator that date of birth is not correct here. So with this information, we can go back to the code and then try to debug. Here we realize that the input type is text. However, for date of birth, it would be better to make the input type as date. So after changing the DOB title to date of birth, which is not important, we just change the input type to date and then save it. Actually, after doing that, we can also use the input type tel for the phone instead of text. So let's also fix that. Now we go back to the browser. We can close the developer console, and now we can try again. We will also notice that now in date of birth, we have a better format. And let's try to enter something random. We still have a problem with date of birth. We will just go back and enter the input. Right, now you will also see that we can use the date selector, which also is making our life easy. And when we add, now it works. As you can see, we have the new record and it got a new ID, which is 15. So it's all very good.